Good morning, everybody, and welcome to week 7 of the CWS Level 1 Preparation webinar course. We are just about halfway through now. After today, we will be basically halfway through, depending on how you round, I guess, since week 15 is actually just a review. And for many of you, we will be doing that in Pennsylvania, in Lancaster at the Eastern Water Quality Association. So today we're going to talk about aeration and adsorption. And so let's go on and get started with that. I'll make sure I get everybody muted here so we don't have the background noise. Okay, very first thing, as always, I'd like to start off by saying thank you. It is an honor to me to be able to serve you in this way. I really, really appreciate it. And it's always my goal to make sure that the information that I give to you is at least as valuable as the time that you're giving to me. I very much appreciate it. Thank you. I also wanted to start off today with a correction on my part, or rather a clarification. Last week we had a question about what media was used to remove sulfur, and I believe I said we'd talked about carbon and KDF and berm, and the question was, well, I thought that you couldn't use berm for hydrogen sulfide, and I knew that there was some berm in some hydrogen sulfide filters, but I did a little research on it and looked it up, and berm itself is not the media that is used for, berm is excellent for removing iron. Berm is in some hydrogen sulfide filters when they are used to remove low levels of iron. Normally what you have for hydrogen sulfide, you have manganese green sand, which works with your potassium permanganate, will remove some. KDF is one of the most popular, KDF 85. And then carbon will remove it, but carbon, we're going to talk some about carbon today. But carbon is going to become exhausted pretty quickly with hydrogen sulfide. So berm is used in some hydrogen sulfide filters, but it's to remove low levels of iron, and so it's not the primary media that is used. So I wanted to clarify that and answer that question that came last week. So it's a good question. And I always appreciate it. If you guys ever have any questions like that you want me to research or get the answer for you, I learn that way too. So I really appreciate the opportunity. So today what we're going to talk about is different types of aeration systems. We're going to talk about open gravity aeration systems. And I'll tell you, today's course, today's lesson was one of the ones that made me decide to finally put together this curriculum, put together this course. I had, as sales manager when I worked at the company I used to work at, I helped a lot of, it was mandatory for our salespeople to become level 1 certified. And as sales manager, I felt like it was my responsibility to help them get there, to study the books and study the material. And when I started Moti-Vitality, and I was out asking people and working with WQA, and why aren't you guys certified? It's a great way to learn the basics of the industry. I mean, I really believe that people that take this course and study the material and go through it, I believe that they actually, in many cases, have more knowledge on how things work than some people that I've seen doing this business for 15 years. While they may not have all the practical knowledge, they have an understanding of how the technologies work. And so I just see this certification and this course as being really, really valuable. But I put together the curriculum because the books, they talk about these open gravity aeration systems or closed pressure aeration systems. And I was thinking, what the heck is a closed pressure aeration system or an open gravity aeration system? Nobody calls, I mean, we all have used the closed pressure aeration systems. We've all used them. That's the things like the iron curtain or the sulfur filters. That's a closed pressure aeration system that we're just talking about. But nobody calls it a closed pressure aeration system. I mean, you don't talk to the customer and say, wow, I think we're going to put in a closed pressure aeration system for you today. Nobody calls them that. And so that's one of the things that about this course is that everything is, they call them names that are not in use in a practical way. So today we're going to talk about them in a practical way. This is one of the subjects, one of the topics that made me actually create this curriculum. We're going to talk about, so there's the closed pressure aerators. Yeah, there they are right there on the list. Adsorption and some about taste and odor. We're going to talk some about carbon, chlorination and dechlorination. So what is aeration? Well, aeration, it occurs in nature. It happens all the time. So if you've ever been to Niagara Falls, the water's being aerated. It's why it looks white. Same thing with the geysers. Aeration is pretty common in nature. We get it all over the place. We get it with anytime you have rapids, anytime you have white water, waves in the ocean create aeration. The definition of aeration is when water is either brought into intimate contact with air or air is brought into intimate contact with water. So this is where we cue the 70s music, right? The water and air, they come in the room together and they have intimate contact with each other, and the air has intimate contact with water, and you've got anyway, fade out. Next slide. Okay, so purpose of it, it is hopefully you guys didn't have a hard time getting on today. Some of you that are coming in late, hopefully it wasn't, I know we had a lot from the webinar that I did on, when was it, Monday. We ended up having a technical difficulty. It took me 15 minutes to get on. If that ever happens, by the way, I just want to clarify that we do have 7 more classes and we're going through here. If the technical difficulties ever happen, just a reminder that call Jen first, okay? Call Jen first because I'm going to be trying to figure out how to get online. I was having trouble with my computer on the webinar that we did Monday, and everybody was really patient, but that's the biggest thing. You're not going to be able to call me to get on because I'm going to be trying to get on. Okay, so aeration purpose, the purpose for it. The purpose is the mechanical reduction of dissolved gases, volatile synthetic organic chemicals, and hydrocarbons, and removal of some objectionable odors by reducing odoriferous matter and the chemical reduction of ferrous, iron, and manganese. I like the word odoriferous too. That's or odoriferous. Odoriferous. There's so many fun words in this webinar. That's yet another reason to put together the curriculum here. Was words like odoriferous. So much fun. In other words, it improves both the physical and the chemical characteristics of a water supply. So the types of aeration systems that we're going to talk about, you have open gravity systems. This is where the aerated water must be repumped to repressurize the surface water. And I'm hoping to have, I just had a customer recently, very recently, that I recommended a company to put in one of these systems, and it's gigantic. He's going to be sending me pictures. I talked to him a couple days ago. He's taking pictures of it and sending pictures to me, and so I'll be able to post those online. I was hoping to have them for today, but we didn't get them yet. Then you have closed pressure systems. These don't require repumping or repressurizing, and let's show you how they work. Okay. So this is an open gravity aerator, and what this is mostly used for are things like methane gas or dissolved oxygen in the water, And I don't think I put the, yeah, I didn't put the video on this yet. I've got a video of what happens with gas that I'll show you guys in I think it's in week 13 that I'll show you the video with the gas. But basically, if you've got gas in the water, then you put one of these systems in, and this allows the gas to dissipate. Let me show you how it works. Let me turn on my little drawing here. You know, you guys love the drawings, right? Okay. So basically, the way this thing works, this is an open gravity aerator, and this is allowing the water to come into intimate contact with the air. Okay, so you've got your well pump here, and this one shows one pressure tank. It shows a pressure tank going in through the untreated water. So your regular well pumps the water up through here, and it brings it into a pressure tank. So the water's still under pressure here. From there, it brings it into one of these guys. Okay, now this is a big storage tank. And there's a couple different designs on them. Okay, but these are big water tanks, and they come in different sizes. Typically, it's a 300-gallon tank. Is what it is. What it will be, 300-gallon water tank. And so you bring that water in, and this becomes essentially the well. Okay, this basically becomes the well, except it's got gas in there, and the gas spins out through this pipe. Uh-oh, what's the noise? Okay, so the gas that's in the water, let's say it's methane or whatever, it will vent out through this pipe, which goes outside, or if it's dissolved oxygen or any kind of odor there, it will vent out through this vent pipe, which runs out through the side of the house. If it's something flammable, then it's got to be above the roof line usually. And then you have a pump, which is here, which acts basically the same way as this guy does. Okay, this makes this a pump. So this takes this water and it pumps it back into another pressure tank, which repressurizes the system. But before that happens, you got this guy up here. This is a chlorine pellet dropper. Sometimes you'll use a chemical injection, chemical feed for chlorine injection, but a lot of times there'll be pellets, and this will drop pellets down into this water, which chlorinates it because you are exposing this water to the outside air. So you have to kill that bacteria in there. This guy down here is a blow-off valve, because if you do have iron or any kind of sediment or anything like that, if it's iron especially, the chlorine is going to oxidize that iron and cause that iron to precipitate down to the bottom, and you're going to have a sludge down there, and you're also going to have debris and sediment and stuff like that. So every once in a while you have to purge that system. So you open up this blow-off valve and maybe whoosh, and you blow that stuff out of there. So the pump pumps it, repressurizes it, comes down through into this other pressure tank. From there you go down into apparently a teeny tiny house and itty bitty softeners and filters. But these are maybe not the scale. So this guy right here is going to be a carbon filter, which is going to remove the chlorine, because remember, this water is going to be heavily chlorinated, but hopefully gas-free. And then from there, because you still got the hardness in the water, from there it's going to run through a water softener, and from there it goes into the house. So that's an open gravity aerator. We are seeing methane is becoming, we're seeing it more and more commonly now. Way back when I was in sales, and way back before hydraulic fracturing was an issue, or fracking, there are natural methane lines that run down through the ground. First time I ever saw that, wow, did it freak me out. I mean, a guy had a bottle, and he opened that bottle. It looked like Sprite when he poured it, or almost milk. I mean, it just had tons of bubbles in it, and those bubbles dissipated, and he actually lit it. So he pulled the bottle cap off that bottle and took a lighter, and it went woof. I mean, it was awesome. There are, because of the fracking around on YouTube, a lot of videos of flammable water now. You can pull that out and look at it online. It's pretty cool. I mean, it's not cool to have it in your water, but it's pretty cool. They're pretty cool videos here, so you can check it out. It's kind of interesting. A couple things about methane and radon. Methane is explosive. You need to vent them both. Radon is also a poisonous gas. They have to both be vented properly. They don't ionize in water, but they remain in free form. So it's sort of like free carbon dioxide. If you have carbonated, carbonated soda like Sprite, then you see the bubbles come to the top. That's the way it kind of looks with methane and radon. Those bubbles will float up because they're lighter than the water. They'll float up through the water and vent out. Temperature matters. So the warmer the water, the faster the gas is going to dissipate. Okay, so but that's what those systems are for, is for the natural gases in the water. Okay. Closed pressure aeration systems, where air is introduced to the water. These are not good for off-gassing because you're trapping them in there. So you're not, this isn't going to be good if you have something like methane or radon or dissolved oxygen in the water. Oh, by the way, let me mention that too. There are some systems out there, if you've got a lot of gas in the water, a lot of that dissolved gas or that like methane or dissolved oxygen, that will lock up systems that sometimes you'll airlock pumps, or it will cause your pipes to spit and sputter. And you know how when you drain your water lines, if you've ever drained the water lines and then you turn them back on, and when they first turn back on, they're like, phew, phew, to the air in the pipes, right? I'm doing all kinds of impressions today. So that was my air in the pipes impression, water coming back in. It made you guys feel like you had just turned the water back on, I bet. That's the way your pipes would be all the time if you have methane. They spit and they sputter, and especially, I mean, they'll shake the pipes like crazy, and it will cause some of the solders to come loose, and you can have all kinds of leaks. Dissolved oxygen, when we talk about corrosion, I'll show you guys some pictures of that, but dissolved oxygen will not only cause that to happen in your pipes, but it'll wreak havoc on the corrosion. If you have copper plumbing, it'll destroy it. It will corrode the heck out of it. Okay, closed pressure aeration. Air is introduced into the water. These aren't good for off-gassing. There's going to be some pressure loss, but that's the case with any filter, right? Because you're running water through it. So anytime you have any kind of a filter or filter media, you're going to have a little bit of pressure loss. But these, they sometimes will do the pressure loss on purpose. And the reason they do that is you have to have the contact time. Sometimes they'll actually use the media itself to help convert iron into, well, berm as an example, okay, and you have to have the contact time. If these, a lot of times these will have an air compressor on them, so the compressor will, I mean, sometimes there's separate tanks. Like here you've got a separate compartment, 2 tanks, one on top of each other, stacked unit. But basically what they'll do is they'll pump air into one of the tanks, okay, and this is your contact time, and what this does is this converts, it oxidizes any of the metals in the water. Low levels of hydrogen sulfide will use air. Higher levels, you're going to need some sort of a chemical oxidizer like hydrogen peroxide or chlorine to help with that. But basically, this first tank is the tank that converts it, and then the water flows through there, and you have a filter media which then filters out everything. Okay, and it's going to be on a timer. Usually you'll filter every 3 days. But the reason they have a lot of, in addition to running through that media, which is going to be pretty heavy media and pretty thick media, in addition to running through that media, sometimes they'll have flow restrictors on them that will, so when they say this is a 7 gallon a minute unit, well, you could put more than 7 gallons a minute through it, but it's not going to function properly. So a lot of times they'll have a flow restrictor on them to keep it down to 7 gallons a minute so that you have time to convert and filter. So remember, going all the way back to week 2 when we talked about filtration, the #1 cause of filter failure is going to be inadequate backwashing. So remember, when you have these kinds of filters, closed pressure aeration systems, remember that you have to have a good backwashing water. You got to have enough pressure to backwash. Okay. All right. So what is adsorption? Now, this is different than absorption. I had somebody not too long ago ask if it was a typo when I put adsorption. No, it's different. Okay. Absorption. That's screen happy there. Okay. So absorption is if you got a guy eating the pie. Okay. That's absorption. Okay. And so the pie is going inside of him. Adsorption is when stuff sticks to the surface, the outside surface. Okay, so absorption, sort of like a sponge when stuff goes deep inside of it. Adsorption is when stuff sticks to the surface. The adsorption process has actually been around a long time in water treatment. The Egyptians use it, the Persians, the Indians. That's where matter adheres to the surface areas of the adsorbent material. It's more of a physical treatment than a chemical. It's similar to the van der Waals forces, which sounds like something out of Star Wars to me. What do we do? What do we use? We need to use the van der Waals. But that's actually not, it's not nearly as cool as that, actually. That was a horrible Star Wars impression, too. So I don't know what's up with me and impressions today, but it didn't sound like any Star Wars character I'm aware of. And I won't even try to do it in the Jar Jar Binks voice, because that's just, that would just be wrong and creepy. So anyway, van der Waals forces are the same thing that cause surface tension. So you know how when you see like a leaf or a seed or something floating on top of the water on a lake or a pond or a river, that's surface tension. Once it breaks the surface, then the stuff will sink down through. Okay, so that's sort of what happens with adsorption. It's a similar thing as the van der Waals forces. It can easily be reversed. So if you have something sticking to, this is basically why when you have a carbon filter in a refrigerator, carbon is an adsorption media. Stuff sticks to the outside surface of it. So why is the TDS usually higher after the carbon filter than before the carbon filter? Well, it's because you've got stuff in there sticking to that carbon, but then as you continue to run water through it, it actually puts more stuff in the water than it takes out, because it actually kicks off the stuff that I had previously taken out of the water back into the water, so you have a higher TDS. I don't know if you guys ever do that when you're in the home, but check the TDS out of their carbon filter that everybody's so proud of. It's almost always higher out of the refrigerator than it is out of the kitchen tap. And that's because the adsorption has been reversed, so you're getting what they call dumping coming back into the water. Temperature will affect adsorption. The lower the temperature, the better for adsorption. Warmer water can cause dumping or desorption. That's what we just talked about. So if you're still getting, with the refrigerator, right, you've got the dumping coming from that refrigerator carbon filter, you know that it's going to be higher if the water was warmer, because lower temperature will actually reduce some of that dumping or desorption. But it's best to have 40 degrees, 55 degrees Fahrenheit, or in case you wanted to know Celsius, 4.4 degrees through 12.8 degrees Celsius. pH will also affect it. It's best if it's below 7 on pH for absorption. In contact time or flow rate, the systems, like I said, will often include flow restrictors, a lot of these will. We use adsorption for improving taste and removing odors, the dechlorinization of water, dechlorinization. So the dechlorinization of water, radon, sometimes words just don't sound right when they come out of my mouth. But I think that's maybe the case with a lot of words that come out of my mouth. I don't know. I'd be scared to go back. Some of you are going back and re-listening to these webinars, and it's got to be. I wonder if it's more frightening the second time. But anyway, radon, the adsorption is used for radon or chlorine reduction and removal. Removal of non-pathogenic organic substances. Synthetic organic compound removal, so pesticides. And selective reduction and removal of inorganic substances such as fluorides and arsenic. So that's I want to point out that that is not the best method. Well, carbon, I don't want you to think that carbon is the best method of removing fluorides or arsenic with carbon. But so adsorption, it's not. You can have adsorptive materials that are not other than carbon. So there are other materials out there beyond just carbon that are adsorptive materials. So adsorption methods, granular, powdered, and block activated carbon. By the way, if once you get your CWS certification, which all of you are going to have in a matter of, what, 2 months, 2.5 months, you will all know whether or not you have received your certification. Isn't that exciting? It's kind of exciting. But then once you do that, we offer the advanced courses, the CWS advanced courses, and one of them is on carbon or on filtration. And you will learn, it's the filtration certified in the CWS Advanced, and you will learn everything you ever wanted to know about carbon and more, lots more. You'll learn a lot about carbon there. You have activated alumina products, is also an absorptive media, and some ion exchange resins will have adsorption as part of their process. Also, dissimilar metal alloy materials. Some of these will have silver in them, which the carbon, which helps with that as well. So that also is bacteriostatic. It will remove bacteria, kill the bacteria, or not remove it, but kill the bacteria. These are used for taste and odor. When it comes to taste and odor, there are only 4 tastes out there. Everything is taste one of these. Speaking of taste, I'd take a sip of my coffee, which tastes delicious. Man, it's so good to make coffee with reverse osmosis water. Awesome, awesome coffee. Why aren't all of your customers doing that? But anyway, you only have 4 tastes. You have bitter, you have sweet, sour, and saline, which is salty. Saline is a fancy, schmancy way of saying salty, right? That's like, I'd like my food to be a little more saline. Could you pass the sodium chloride, please? Oh, I'm so fun at dinner parties. And then you do have over 20 smells, though, like tons of smells. You've got cucumber, earthy, fishy, grassy, sulfur, which some of them sound kind of nice, right? I mean, you're like, oh, earthy, that sounds so sweet. Cucumber, oh, yum, so nice, but no, that's not good. Some of them are you know, if you get them too nasty or too strong. One time I chlorinated my well. I had in terms of smells, I went to chlorinate it, and you're supposed to take 2 gallons of bleach and dump it down into the well. Actually, just to clarify, some states, some places, you're not allowed to dump anything in the well. It's against code. You have to have a licensed person do it. But the EPA actually recommends that you chlorinate your well if you have a private well once every, well, usually once a year. All I had was, you're supposed to take 2 gallons of bleach, and I had 1 gallon of this floral scented stuff and another gallon of regular household bleach, and I poured that down into my well. And when I went to run the water, I let it sit there for 8 hours, 10 hours, and when I went to clear it out and run all the faucets in the house, oh my God, my house reeked so bad from that floral bleach. smelled almost like that stuff that, remember that orange stuff when you were in elementary school that they put on the, when the kids got sick, and they put that orange powder stuff? Remember how that smelled? That's the way my house smelled. It was so nasty. Anyway, hope you guys are enjoying your breakfast and your coffee and everything else now that I've just talked about, elementary school, all that. Anyway, we'll move on. Station odor removal. So the city water, city often uses chlorine or chlorine plus ammonia, which is chloramine, to disinfect the water supply. Smell and taste is stronger when the surface water is the source. You usually have stronger smell and taste when surface water is used. But chlorine is, the problem with chlorine is it creates a new byproduct contaminant like trihalomethane. So here's the thing with chlorine. Okay, so we've been talking about this on our MD Pro call too, on how to approach this. But the MD Pro call, by the way, Thursday mornings at 8:30. Sales professionals from all over the country. We get on there. We don't talk product. We don't talk company. We just talk water treatment industry, sales, and how do we become professional out there. So Thursday mornings, free call, up on there, information. We'll let you know. It's go to the seminar page on Moti-Vitality.com. So anyway, when you're talking about, chlorine is actually a pretty good disinfectant. When you think about the fact that the United States treats water for the millions of people that it treats water for, they actually do a pretty good job of making the water potable, making it drinkable. But chlorine should not be used once it goes into the house. It's good to use because we can treat it and it has a residual effect. So once it's really good, as it runs all the way through, to have that chlorine, as it runs all the way through those underground water supply systems, and it just keeps the bacteria out of there and keeps you from dying. So that's good. It's cheap, it's inexpensive. Cheap and inexpensive might be a little redundant, but once it gets to the house, you really should be taking that chlorine out, because chlorine is absorbed through the skin. Trihalomethanes are known carcinogens. It's not good for you. It's not good for you to absorb that stuff through the skin. However, you got to be careful how you approach it with the customer, right? There's a good way. We got to educate them. You've got to make sure that they understand. There's so many resources out there that you can direct them to learn about chlorine and trihalomethanes, that we don't have to go in there and go, oh my God, you're drinking that water, you're gonna die. Oh yeah, make a formula with that. Oh, what a cute baby. Too bad that baby's gonna get cancer. That is not the way to go about selling this stuff. And unfortunately, there are some in our industry that do that. We cannot use scare tactics. We just can't use them. But it is important to legitimately educate our customers too. Just do it through resources. Make yourself a professional and do it through resources. I've heard people give presentations that are almost that dramatic. That's the bad thing, especially in the arsenic issue. Here in Michigan we have that, but anyway, that's a whole other issue. It does affect the beverages made with water. I don't know if you've ever had that, where you go somewhere and you taste like where they have the soda machine, and that's pretty nasty. You can tell it definitely affects the coffee and the tea, even just water. Sometimes you do. That is one of the downsides to having a reverse osmosis system, is that you get spoiled with good quality water, and then you go out somewhere and they have chlorine in the water or something else in the water, and you're like, this is nasty. Okay. Taste and odor removal. So the most common removal method is an activated carbon medium. It's the most widely used and most versatile in the water treatment industry. It's known as a scavenger medium because it takes a lot of stuff out of the water. It absorbs a lot of stuff. The only problem with that is because it does so much, you got to replace it more often. So it will remove organics like trihalomethane, synthetic organic compounds like pesticides, detergents, and hydrocarbons. So it does take this stuff out. It is really good for that. this is the way carbon, if you were to look at carbon under a microscope, this would basically be the way it would look, except it wouldn't be a drawing. It would actually be like a real, and you wouldn't have if you looked at it under a microscope, you wouldn't see like the words. It wouldn't be labeled. Carbon doesn't come with labels, It doesn't. When you look at it under a microscope, you won't see words like diffusion path or GAC surface or microfluor or solvents or anything like that. But basically, what you have inside carbon is you have all these little crevices. When we talk about it, when we do the advanced course, they talk about it as being a parking lot. So if you have big things like semi-trucks in there, then it's going to remove less, and it's actually going to block. So like if this was a parking lot, all these little crevices inside the carbon, and a semi-truck parked here, then it prevents other smaller things from getting in here to the surface area of these tiny little crevices. So they talk about small cars and big trucks. I like big trucks from Southern Indiana. I always get excited when they talk about semi-trucks when we did the filtration class. I'm like, yeah, big truck. Ooh, all right. So watch me an episode of Storage Wars next. But anyway, so carbon goes in, and you've got these. You've got these little crevices, so stuff goes inside, and it not only sticks to it's not just this round, smooth little piece of thing. Stuff goes in here, and it doesn't surprise me a bit, Jim Smith. It is a great show, good show, and you can find some really good deals at other people's storage facilities, I guess. Anyway, so you've got all this surface area up inside this that it's not just on the outside. So you've got all these little crevices there. Okay. Carbon can harbor microorganisms. The thing is, it will breed. They are great breeding grounds for bacteria, which can enhance the smell. You can get a nasty smell. By the way, I may have mentioned this once before, but if you have a carbon filter because of all of this, if you're on well water, a carbon filter should never be used in a pre-position. See, I'm gonna give you a disclaimer on this. But if you put, I'm going to kind of explain a little bit of this to you, just as a practical thing. The book does not talk about this at all. This just comes from experience from being in the field. Okay? If you are on a well water situation and you have just like one of those little 10-inch carbon filters or a BB filter or even a 20-inch carbon filter, you put that thing in a pre-position on a water softener, before the water softener, it's going to cause smell. It will increase smell, and this happens pretty commonly. Okay, because a lot of times when you go to the store and you see the little C1 carbon filters, which are junk filters, a lot of times they'll just take a really thin layer of carbon and they'll wrap it around this paper shell and put a mesh on it. And it says for taste and odor. So somebody's got a little light smell in their water, right? This really, it's kind of got this mild odor. So they have a sediment filter already installed on their softener. So they go to the store and they go, oh, well, this says it takes out odor. I'm going to buy these and put these in. And they put those in, and for about a week, they're great. Water's better. Yay, no smell. But then, wow, boom, here comes the smell back worse than ever. I mean, it's nasty. It just creates this nasty smell. And that's because you've got this bacteria. That carbon has captured everything or taken a lot of stuff out. It's absorbed stuff, but then the carbon's exhausted, and those little filters can't backwash. So it actually will create this nasty, disgusting, nasty smell. And so here, I'm getting a question here. Let's see. Would you recommend using carbon paper or granulated activated carbon cartridge when dealing with fixed odor? The paper, I don't like the paper, because the carbon paper, it just exhausts so fast. I mean, it's just this little thin layer. They're more expensive, but I like the GAC filters, the ones that have, that put they're basically a canister full of carbon, and the water runs through them. They're going to last a lot longer. So I prefer those. I mean, the paper ones, especially on well water with high TDS, they're going to go so quick. Now, that all being said, you are if you have chlorine in the water, like city water, then you should use carbon in the pre-position because you need that carbon to take the chlorine out of the water to protect the resin, the water softener. So, but I've seen that. I've gone out to customers' houses and I've changed it. You know, they go, man, our water just started smelling. We've been putting these filters in, but we got to change them every 2 weeks because the smell's just horrible. Well, put a regular filter in. Now, you can put that carbon filter in and put it in the post position, and this is actually a good idea, okay? Anyway, this is a good idea just to have. So, so they've got a sediment filter. Sediment filter is good to have before any water softener, okay? It's good to take that debris and those chunks of sand and sediment that might come out. Even on city water, you're going to get that because things are going to break off in the water lines and the pipes, especially if you're at the end of the water line. You'll get some sediment and debris sometimes, but so it's good to have a sediment filter on a water softener. Although it's better to have a sediment filter than to not have a sediment filter, it's better to not have a sediment filter if you're not going to change it often enough. Okay, they will breed bacteria. And so sometimes if you have somebody who's elderly or somebody who's never going to change the filter, although it's a great time to put them on a service plan if your company offers that to have them go out and and change those filters on a regular basis. But putting a cartridge filter in the post position is not only good to remove chlorine or to kind of if you have smell, a little bit of odor, it's going to kind of polish the water up before it gets into the house. But that also gives you access to all the water lines, easy access, so that you can, if you need to disinfect your water lines, which does happen sometimes, right, where you need to, even on city water, if you're taking all that chlorine out before it gets into the house, every once in a while, you should run just a little bit of bleach, a little bit of chlorine through your water lines, keep those lines disinfected. And then having a post-filter cartridge on that softener will do that. That actually gives you easy access. So you can take a quarter cup of bleach, put it in that filter housing and that cartridge housing, and then turn the water on, let it run through the water lines. That will do it. By the way, just on a side note, just coming from sales experience, a lot of companies out there, a lot of salespeople refer to those filters, the cartridge filters on before the softener as a pre-filter. I never like to do that. I never like that term because I mean, it is a pre-filter, but it doesn't really tell the customer what that's doing. I always refer to it as a sediment filter or a particulate filter, because a pre-filter kind of indicates that you have to have that in order for the softener to function. The water softener does something completely different than filter. The water softener doesn't filter at all. The water softener is, I mean, it's ion exchange. So I like to refer to those cartridge filters as sediment filters. It explains what it does. It kind of explains it to the customer. But anyway, getting back to the carbon here, carbon can harbor microorganisms or non-pathogenic, so they're not going to be disease-causing. And now I will tell you, I have always learned from WQA or from other people out there that carbon should always be used in a post position. However, I'm going to tell you this: carbon will bind up. I have a couple clients, a couple customers who use carbon if they're putting them in a tank, in the tank, the backwashing filter tank. They will put those in a pre-position. Even though the carbon tends to foul a little faster in their pre-position, what ends up happening, the reason they do that, especially if they have iron in the water, the reason they do that is carbon will tends to bind up iron in the system. So if you put that thing in let's say you put it in the post position, a big tank in the post position, okay, and customer forgets to put salt in the water softener, or for some reason the softener fails, and the softener allows a lot of iron through that water softener. Now you've got iron in the carbon, okay, because the carbon will bind up and hold some of that iron. So that iron went through that water softener and it's stuck in the carbon. Even if you put salt back in that softener and get the softener functioning again, you're still going to get staining because the carbon is going to slowly release that iron, and you're still going to get staining coming out. Even if you're still taking out the odor and everything, the carbon will release some of that iron, and you'll get staining. So a lot of companies that I know, you know, if that's the case, if you get that carbon iron fouled and it's releasing a staining, doesn't matter whether it's still taking the odor out or not, customers aren't happy because they're getting staining, which means you have to prematurely change that carbon anyway. So there are some companies out there who put those big tanks, the carbon tanks, in the pre-position when there's iron in the water, knowing that you're going to have to change the carbon a little more often in that pre-position, but understanding that the water softener will then take the iron out that so you don't have to worry about that carbon getting iron fouled and having to prematurely change it because it was iron fouled when the customer, which I know probably all of you listening, none of your customers ever forget to put salt in their water softeners or bypass them accidentally or whatever, but there are, believe it or not, some people have customers out there that don't maintain their softeners properly. Okay, so carbon can harbor microorganisms, non-pathogenic. Wow, we spent a lot of time on that one. Carbon has a lot of surface area. Surface area generally carries a negative charge. Molecules with high water solubility are more difficult to retain, so they'll hop off that carbon easier. Dechlorination. Industrial plants may feed a solution of sodium sulfite. The most common method is activated carbon for removing chlorine. Best its pH range is 6.5 to 7.5, and water temperature between 60 degrees and 80 degrees Fahrenheit. Carbon should be soaked for a few hours before use. There will probably be some carbon fines when you first turn the water on. So I don't know if you guys have ever changed a filter in a reverse osmosis system, but you know how when you change that filter, you put the new carbon filter in, how you turn the water on and it comes out black sometimes? Those are carbon fines. It's the dust from producing the carbon. Again, I recommend you take the filtration course that we have to offer. It's only a 5-week course. You're going to learn tons about carbon in that, but those are carbon fines. pH and totazole solids will be higher when the carbon is new. It does go down. It does drop. TDS drops and the pH comes down as well. The design of carbon filters, they can be tank type or cartridge. Cartridge type, you need to change at least every 3 months. Put in the post position on well water, we already talked about that. The tank type usually have a 30-inch bed depth. There's a valve for backwashing them a lot of times, sometimes not. Sometimes it's just a big tank filled with carbon, and they'll have countercurrent service, and that sort of flips the carbon and lifts the bed as it's flowing through countercurrently. But most of them out there do have a valve on them for backwashing. You need at least 5 to 7 gallons a minute backwash carbon. And again, they can harbor harmless bacteria. So if you get that odor, that smell coming from it, it actually can create smell. Backwashing with hot water will prevent the smell, the bacteria growth, and it extends the carbon life. You should replace the carbon when the bed's exhausted, and assuming you're not taking out any bad things, there's really no dumping restrictions in most places for carbon. It's just charcoal is what it is. I mean, a lot of times they make it out of coconut shells or there's lots of different substances that you can use to make and produce carbon. Usually a timered valve on these, so they'll backwash every 2 to 3 days. A lot of companies out there will add carbon directly to the water softener. It's done to protect the resin from chlorine. I'm not a huge fan of doing this, and the WQA does not take a stance on this either way that I recall. This is a personal opinion of mine. I'm not a big fan of putting carbon on top of the softeners. Now, I know that there are companies out there who do it. They do it very effectively, but the carbon always fouls before the resin does, and it will mix in with the resin, and you end up having to change the resin bed prematurely on the softener. So I'm not a huge fan of doing that. I prefer separate tanks, but again, I know that there are companies who do it very effectively. The resin will degrade if there's more than a part per million of chlorine in the water. Free chlorine residual in the south can be 2.5 to 5 parts per million of chlorine. And that's because it takes a lot more, the warmer the water, the more chlorine it takes to maintain a residual. Okay, so when you get in the south, like in Florida, you got huge levels of chlorine. They have to have it there in order to maintain that residual. But anybody who's ever tested a pool water, they tell you needs to be, what is it, 3-4 parts per million? So sometimes you're going to be way higher than even swimming pool water with that chlorine. It's pretty strong. So the warmer the temperature water, the more chlorine a city has to put in order to maintain a residual. Okay, other dechlorination methods. I'm not going to talk about these a lot. The book goes into a little more detail about them. I'm just going to kind of go through pretty quick. But you can use a high purity dissimilar metal, copper zinc alloy medium. So it's KDF 55. By the way, the type of KDF that's used for sulfur when I was doing the research, KDF 85. KDF 55 is smaller, the smaller medium. It's often used in combination with carbon, either tank or cartridge filter, but it requires a 15 to 25 gallon per minute to backwash. If you're using this, it's pretty heavy. Dechlorination occurs through the sacrificial action of the zinc in the alloy. Chloramines are pretty common. A lot of cities are going to chloramines. Chloramines are caused from using ammonia and chlorine, and this allows the residual to last a little bit longer. It creates fewer trihalomethane, CHMs. It is harder to remove. Not just simple basic carbon won't always remove it. You need to have black carbon and definitely more contact time. Will kill your fish too. If you have chloramines in the water, it's definitely going to kill the fish. Fish don't like it. But the good thing is, if you have a lot of that in the water and the fish die and they start to rot, then it kills the bacteria too. So, you know, there's always a positive from it. Chloramines, mostly in cartridge filter form. If you're going to take those out, if you can't take the chloramines out, usually they're a cartridge form. Other taste and odor conditions. Odors can be caused by organics in surface water. Taste can be caused by high mineral content. Both can be caused by industrial pollutants. And usually you'll take these out in cartridge filter. You can remove, taste can be reduced by carbon, but carbon's not always the best long-term treatment. I mean, sometimes it really depends on what's causing all of these things. It's like sulfur. Okay, carbon, you could put in a sulfur carbon filter for sulfur removal. But depending on how much sulfur there is in the water, that carbon is going to foul pretty quick. So it's sort of like taking, if you have a leaky roof, putting a bucket under the leak and using that as water treatment. That's the way carbon is sometimes. Okay, that's not necessarily the best choice, not the best option. The best option would be to fix the roof. Color in the water, a lot of times are caused by tannins or humic acid. Basically, if you've never seen tannins, then you're missing out because, wow, they're awesome. It's so awesome to see water that somebody fills a white bathtub with or hot tub, and it looks like somebody peed in it because it's got this yellow tint to it. It's like somebody put yellow food coloring, or maybe sometimes it's slightly greenish tint as well. But those are tannins, or humic acid. They're caused from decayed vegetation, leaves. In fact, if you go to a house, a lot of times if you look around, if they're on a well and they've got wetlands around, or they're in the woods, a lot of streams, a lot of marshland, could be that there are tannins in the water. Tannins they're not going to do any harm. Except in a commercial application, it's usually just aesthetic, so they're not going to hurt anything. It's just that people don't like bathing in water that looks like somebody peed in. I mean, so you get those out. You can take those out. You can remove it by reverse osmosis for drinking, but also you can use an anion tannin resin, so anion exchange. By the way, real quick, let me explain to you how just a little field test of the anion resin. You have to reduce the alkalinity below 35% of the total dissolved solids and the pH below 8.5. So a lot of times you have to have a citric acid, add a little citric acid to the brine tank when it goes to regenerate. But if a lot of people don't carry a tannin test kit with them, so let me tell you real quick how to determine whether or not you have tannins in the water or oxidized iron. Because see, a lot of times, because oxidized iron will cause a yellowing color of the water too, right? Because if you have oxidized iron, precipitated iron. So if you got a lot of iron in the water, here's one of the quickest ways to tell whether or not it is tannins or whether or not it is oxidized iron. Because see, tannins will show up on most of the iron tests that we have out there. Tannins will show up as iron on the iron test. So most of you have a mini water softener. Run the water. You test it. Let's say you have 2 parts per million of iron in the water, right? Now you run it through the your mini softener, and you still have a part per million of iron left in the water. Now that could either be oxidized iron or it could be tannin, and that could be what's causing that yellowing color of the water. So I would recommend buying from somewhere, anywhere you can get it, anywhere you get your chemicals. You can get these little 1-micron pleated filters, and you carry those in your test kit if you ever run into this. Or if you don't have those, then grab 5 coffee filters and put 5 coffee filters in a row. Stack them. And so take that softened water with 1 part per million of iron in it, let that drip through those 5 coffee filters, and retest the water. Now make sure you've rinsed out your test tubes with RO water or something to make sure that you've gotten all the iron out of your test tube. So retest that water. If you still have iron in the water, then probably it's tannin. Because if it was oxidized iron, those 5 coffee filters would remove it. 5 coffee filters in a row would remove the oxidized iron. So that's just a real quick little, how to test to see if you suspect tannin. So you can't oxidize tannin. Okay? And we'll talk about that one more down the road. But you can't oxidize, you can't aerate tannin. You've got to use RO or the anion resin to take it out to the whole house. Again, there are some companies out there who use mixed beds, so they'll put tannin resin in with the softener resin. I don't like doing that. I like separate tanks for the same reasons we talked about with carbon. Fluoride reduction. I'm not going to get into the controversy on fluoride. I'm just saying that, and I don't think you should with your customers either, but fluoride does have a maximum contaminant level. You should have no more than 1 part per million in the water. Problems can occur when there's more than 2 parts per million in the water, and osteoporosis can occur when there's more than 4 parts per million in the water. And the United States loves to put fluoride in their municipal water because they say that it will help the bones, and maybe it does. I mean, I'm not a dentist or a doctor or anything like that. I do know that I'd rather err on the side of caution. For me, I like taking it out and then using that little mouthwash to axe stuff in my teeth and things like that. Let your customers determine that. Recommend they ask their dentist. And then and there are tons of places that they can go online, do research about fluoride to determine whether or not they want it in their water. It does occur naturally in most natural groundwater supplies in trace amounts, so it is not some government conspiracy that that was invented in World War II. Go to a health and fitness show sometime, and one of the little health and fitness shows. Go set up a booth, and you will hear the craziest stuff from people about everything that you've ever heard about with water. So it's not some, I don't know. Anyway, it's naturally occurring in most natural groundwater supplies and trace amounts. It can be removed by RO or distillation. You can also use activated aluminum. That's it. So next week, we're talking about the troublesome trio, iron, manganese, and more about sulfur. I do want to invite everybody to join us on Thursday mornings. It's awesome. We have a great call. It's free. The information is on the seminars page. It's a Thursday morning call. It's a half hour. It's free sales training. We always have great conversations. Right now we're studying how to win friends and influence people, but it's just very loosely kind of going through that. Also, we have a certified installer course starting August 15th. And so if you have installers that are interested in that, let us know. We'd be happy to sign them up. Thanks, everybody. Have a great week, and we will talk to you next week, if not sooner.